Hi friend, good morning and welcome to my YouTube channel CivTech Simplified, where we discuss various multiple choice questions and videos relating to exam preparation materials in civil engineering. Our today's topic for discussion would be building constructions and building services. My name is Engineer Imran Aziz and I will be bringing you here 25 questions and explaining them through the pictures as well as the explanation notes. I am a civil engineer having 20 years of field experience in multiple sectors within civil engineering. And today's topic for discussion is building construction as well as building services. The correct answer will be shown as highlighted in the text so that you could refer it, and we will be explaining each slide. Each slide will be having one question, and overall 25 questions will be discussed in this lecture. So let's get started with today's topic and its questions. If you have any questions, you can write down in the comment, and I will definitely answer them in the next video, or you can refer to me through email, which is civtechsimplified@gmail.com. So let's begin the topic with part one. Question number one with us for today is: the stretcher bond in brick masonry can be used only when the thickness of wall is. Options available are 90 mm or 3.5 inches, B 180 mm, number C 190 mm, number D 280 mm. So the correct option for this question is option A, 90 mm or 3.5 inches. Question number two, the type of bond provided in brick masonry for carrying heavy load is. So there are various bond types. We will be discussing them in the following series slides. After a few slides, we will be discussing the bonds and their types with pictures, and I will explain them in those series with the help of some pictures, so that you should be having an accurate and exact knowledge of the bond types, because these are the common questions we come across in various exams. These are related to bond types and their specifications. So here question number two, I will again read: the type of bond provided in this brick masonry for carrying heavy load. Options available with us are A, single Flemish bond, double Flemish bond, C, English bond, D, zigzag bond. So the correct option for this question is English bond. We provide English bond to carry heavy loads in a building. Question number three, a queen closer is a. What is queen closer? Most of you will be familiar with this. Option A is brick laid with its length parallel to the face or direction of the wall. So it's not, I think. Brick number B, brick laid with a breadth parallel to its face or direction. First was length and second is breadth, but the option is parallel for those. But queen closer is never placed parallel. We know. Number C, brick having the same length and depth as the other brick, but half the breadth. Brick with half the width at one end and half the width at the other. So option C is correct for this question. Queen closer is a brick having the same length and depth as the other bricks, but the half the breadth. So its width is basically half. Breadth is half, but length is same, and depth is also same as per the other bricks used in the wall. Number four, the stone suitable for rubber masonry should be. Now, properties of stones has been discussed in this question. In rubber masonry stone, which stones should be suitable? Number A, hard stone. Number B, tough stone. Number C, heavy stones. Number D, light stone. Option for this question, correct option is A, hard stone. Stone should be hard enough to withstand the load of the structure, but it should not be so tough to be used. Should not be so heavy, should not be much lighter. So the correct option for this question is A, hard. Number 5, minimum thickness of wall where single Flemish bond can be used is number A, half brick thick. Number B, 1 brick thick. Number C, 1.5 bricks thick. 2 bricks thick. Correct option for this question is C, 1.5 brick thick. Minimum thickness of wall where English Flemish bond can be used. So that wall should be 1.5 brick wall thick, like 13.5 inches wall thickness should be there where you want a single Flemish bond. So it's not used for 4.5 inches thick wall and neither used for 9 inches thick wall. So the minimum thickness of that wall should be at least 13.5 inches where we want to use the single Flemish bond. So question number 6, which of the following should be used for hurting of thicker walls? And number A options are headers, number B stretchers, number C brick bats, number D queen closers. So for hurting the thicker wall, headers are used. Option A is correct for this question. Question number 7. In brick masonry, the bond produced by laying alternate headers and stretchers in each course is known as. In brick masonry, the bond produced by laying alternate header and stretchers in each course is known as number A, English bond, number B, double Flemish bond, zigzag bond, and single Flemish bond. Correct option for this question is double Flemish bond. So we will be showing some pictures of these bond types because one should be clear while we are discussing types of bonds. So after looking at the pictures, you will be more clear. So you see, if on your left we have placed a picture for English bond, and then on our right it's Flemish bond. So you can easily compare both types of bonds. If you see here in English bond, there is a layer of stretchers and then headers at the top, and then stretchers and header. And on the Flemish bond, uh, one brick is laid in stretcher and the other in header, and alternatively similar. These are the differences between header and English and Flemish bonds. We will discuss them in the next slides as well. So question number 8 is again within those bond types. It is the brick laid with its length parallel to the face of the wall is known as. So the brick laid with its length parallel to the face of the wall is header, stretcher, closer, none of these. So we already we saw in the previous pictures, and we will also show you the next picture. Correct option for this question is definitely stretcher. Stretchers are always laid parallel to the face of the wall. You can see in this picture, this is called stretcher bond on our left, and on our right it's the stack bond. You see, stretcher, as we discussed in the previous question, stretchers are the bricks which are laid parallel to the face of the wall. So this is the common example for this type of bond as well as type of brick. And then it's the stack bond. Stack bond, we all know that in stack bond only structures are placed, and this is the weakest type of wall. It is not recommended in the constructions. Then we have some other types of bonds, which is zigzag bond, normally used in brick pavings and some of the walls, and for decorative purposes. And then garden walls, we also use these type of non-load bearing walls. So you can see the pictures and have an idea that what is basically zigzag bond and what is garden wall bonds. So next question is number 9, snow loads. So we already discussed in our previous lectures. You can always search load types lecture at CivTech Simplified. It's available. We have already discussed in very much detail about various types of loads, their types, their combinations. All have been already discussed in load type video. But here it's a common question, which is snow load, which is about snow load. Snow load is considered as number a dead load or live load, water load or wind load. So definitely it's a live load. It's not a dead load of the structure. It is coming somewhere from uh, out of the structure. So it's a live load and maybe for a shorter period of time. So normally it's a general question whether it is dead load or live load. So we take snow load as a live load. Question number 10. Load bearing structure transferred the load to subsoil by number A, columns, number B, columns and beams, number C, masonry walls, number D, none of the above. So correct option for this is masonry walls. So load bearing structures transfer the load to subsoil through their load bearing walls. Question number 11. Which is the part of substructure out of the following? Which is the part of substructure out of the following? Options available with us are number A, plinth, number B, foundation, number C, dam proof course, DPC, number D, walls. So out of these four, substructure is basically a structure which is in the soil. You can generally say uh, not above the soil or the finished floor level. So it's option B, which is foundation. Foundation is always considered as substructure. Question number 12. Dutch bond is a modification of. Yes, Dutch bond is a modification of number A, English bond, stretcher bond, header bond, single Flemish bond. So yes, Dutch bond is a sort of modification as well as improvement in the English bond type. So A option is correct for this question. Dutch bond has been derived from English bond technique. Number 13. In ordinary residential and public buildings, the dam proof course is generally provided at where we provide DPC. And why we are clear on this, that why we provide DPC, just to control the dampness to raise up in the building from the soil. We provide a small 2 inches thick layer of PCC concrete above the plinth level. So yes, generally it is provided at plinth level. Option A is ground level, B is plinth level, C is water table level, and midway ground level, option D. So yes, option B is correct. We provide DPC at plinth level in a structure just to control the dampness to raise up in the walls. Number 14, a covering of concrete placed on the exposed top of an external wall is known as. We provide a covering of concrete at the exposed top of an external wall mm, the wall which you don't have further any structure or something, it has already ended at the top. So we provide a small, similar, just like DPC, we provide a coping at the top of that wall. So yes, option B is correct, which is coping. Options available for this question were A, concrete, B, coping, freeze, and lintel. Cornice, coping, frieze, and lintel. So option B is correct for this question, which is coping. Number 15, the bond in which header and stretcher are laid in alternate course and every stretcher course is started with a 3/4 brick bat is known as number A, English cross bond, number B, Dutch bond, monk bond, rat trap bond. So correct option for this is Dutch bond. So Dutch bond is basically bond in which header and stretcher are laid in alternate course. First condition, yes, they are placed in alternate course. One course will be header, the other course will be stretcher, and the third course will again be header, and fourth will be stretcher. So one condition is this. The second condition is every stretcher course is started with a 3/4 brick bed. So every stretcher course will be started with a bat. I will show in the picture so that you should be clear. We will compare this in the following slides as well. So this is basically an example of Dutch bond. You see at the top, it's all header course, and then in the second one is the stretcher course. But you see, if this stretcher course is starting with a 3/4. You see here, it's a 3/4 brick bat. So this second course, you see, second course is a stretcher course, and it is starting with a 3/4 brick bat. So again, it is clear now that Dutch bond has been derived from English bond, but it is starting. It is a sort of modification of the English bond. It is starting with a 3/4 brick bat. Question number 16: the minimum width of a stair in residential building. In a residential building, the width of stair normally we provide it as a 4 feet stair, but yes, minimum, if you have space constraints, then you can provide up till 2 feet 9 inches. So option A available with us for was 55 centimeter, option B 70 centimeter, option C 85 centimeter, option D 100 centimeter. 100 centimeter is highly recommended and normally used, but if we have space constraints and we have to provide a minimum standard, so it's 85 centimeter, 2 feet 9 inches. 100 centimeter is highly recommended. But number 17, as compared to English bond, the double Flemish bond is. So here is a comparison of both the bonds, English and Flemish bond. So options available were number A, stronger, more compact, number C, costly, number D, none of the above. So as compared to English bond, double Flemish bond would be more compact. It has more capacity to withstand the loads. So option B would be more compact, and I will show it in the picture. We will be comparing both the bonds in the next picture. You see, on your left, it's an English bond, and on our right, it's a Flemish bond. So you can see with the eyes that Flemish bond is sort of more compact and more solid as compared to English bond. And it has definitely, if it's more compact, so more capacity to withstand the loads. And You can also compare the making of the bond. English bond is having the lowest course as the stretcher course throughout, and then on our right in the Flemish bond, it's again that queen closer is given, and then we have first one is header, queen closer, and then stretcher, then header, then stretcher, header. So queen closer is provided at the start after every header. But here in the English bond, you can see it's a complete stretcher, so it's not so much compact as compared to Flemish bond. So next question is 18. Question 18. The thickness of a reinforced brick partition wall is generally kept. Brick partition wall. Partition walls, those walls which are normally non-load bearing walls, normally given in the washrooms, in the toilets, or maybe some parda walls, or etc. So any non-load bearing wall, so its minimum thickness should be uh, 5 centimeter, option A, number B 10 centimeter, option C 15 centimeter, option D is 20 centimeter. So it should be 10 centimeter, which is normally 4.5 inches. So question number 19. Brick nogging type of partition wall is constructed by. I will explain this brick nogging in the next slide. So as I discussed earlier, we are not just throwing the MCQs. We are here explaining the tricky terms, explaining the concepts, so that people should be familiar with these terms, and this knowledge should remain in their minds while they are preparing for the exams, or uh, in the practical life. So I will show this nogging with the pictures, and you will be clear in the next slide. So a question here was, brick nogging type of partition is constructed by number A, laying brick as stretcher in cement mortar, laying brick as header in cement mortar, reinforcing brick wall and iron steps. Number D, constructing brickwork within a wooden framework. Yes, nogging is always given in a wooden frame. So here is the explanation of nogging. Nogging is basically a construction technique using brickwork to fill the spaces in a wooden framed wall or partition, providing structural stability, fire resistance, sound insulation, and thermal mass. In the old days, it was a common method in traditional timber framed and masonry buildings, with the brick either remaining exposed or being covered by a plaster or mortar layer. So, nogging is basically a partition wall which is constructed in the wooden frames. You see here we have wooden frames in our left and right picture. So within those frame, we just fill in the area with the help of the bricks. Normally it is zigzag course. Uh, so it's basically load is transmitted through that wooden frame, but the filling part is done through the bricks. So this technique is called nogging, brick nogging. It was used in the older era when even the filling was done through stones or through the bricks. But the main thing is the wooden frame. This is, you can say, semi wooden type of building, not completely wooden and neither completely brick. So both the building materials have been utilized. Normally, it is not used in the like latest or the current era, but these buildings were constructed in the past. So next we have question number 20. dash in a building means the free passage of clean air in a building. It's very important. There should be a free passage to circulate the air within a building, and that building should be ventilated. Number A option was habitation. Number B, protection, sanitation. Number D, ventilation. Yes, of course, it's a ventilation. We always provide a free passage for the clean air to circulate within the building, and that process or that technique is called ventilation. So option D is correct for this question. Question number 21. The science which deals with the sound insulation in a building is known as sound. Sound refers to the acoustic property of a building. Number A, option available with us for A, reverberation, number B, transmission, acoustic, and airborne. So option C is correct for this question, which is acoustic. So science which deals with the sound insulation in a building, that that branch of science is known as acoustic. The 22, the part of building above the ground level and up to the floor level immediately above the ground is known as. So that portion is above ground level, first condition, and up to floor level immediately above the ground. So it's above the ground, but not above the floor. So medium ground and floor, in between ground and floor. So what will be that area? Number A, plinth area. Number B, formation level. Number C, ground level. Number D, plinth. Yes, it's a plinth. Plinth is the part of the building above ground level and up to floor level. So immediately above the ground is known as plinth. Number 23. The dash provides support to occupant, furniture, fixtures, and equipment of a building. Number A, plinth. Number B, ramp. Number C, floor. Number D, lifts. So plinth is outside the building. It's not providing support to occupants. Ramps are also outside the building. Floor, number C, floor. And lifts are also used for other purposes. So option C, floor. Floor provides the support to occupants, furniture, and fixture. C is correct for this question. 24 dash is the part of building constructed above the plinth level. Dash is the part of building constructed above the plinth level. Number A, plinth area. Number B, superstructure. Number C, substructure. Number D, formation level. Yes, it's superstructure. Superstructure is always above the plinth level. We discussed there are normally three levels. One is superstructure, then plinth, then we have substructure. Substructure we already discussed here. So here the option B is correct, which is superstructure. Then we have question 25, the last question of this topic. This part, plinth, dash is the topmost part of building which provides covering to the entire assembly and the occupants. So which is the topmost part of the building which provide covering to the occupants? Number A, roof, ceiling, coping, and parapet wall. Of course, it's A, roof. Roof provides the covering to the residents inside the building. Ceiling is always down the roof. Coping is somewhere provided in the outside walls, which are not normally covered. Parapet wall is also an outside structure. So roof is the part of the building which provides coping, which provide covering to the entire assembly and the occupants. So A is correct for this question. So thank you for watching this video. We have discussed so far 25 questions in this topic, and these were fully explained. These videos are suitable for professional engineers, fresh engineers, and people struggling to prepare for the exams in FPSC, SSC, JE, RRB in India, and KP in Pakistan. and even Punjab, Sindh, or other provinces professional exams. So I will again urge to subscribe this channel on YouTube, follow it on Instagram, Facebook, and support me at TikTok as well, so that we bring more knowledgeable material for you people, and you are well equipped to prepare for the exams. So thank you very much for today. I hope you have learned a lot, and I will be bringing more fruitful knowledge in the future. Thank you.